Good morning. My name is Chris Rogers. I'm the founder of Solenergy. We are a product non-specific supplier of solar and standby power systems. And the name Solenergy is a play on the word silent and energy, because that's pretty much what we do. Not only obviously solar panels being quiet, but the inverters and batteries and stuff that we use are usually heat sink based, so no noisy fans and stuff like that. So that's that's kind of the origin of our name. So we focus on the high-end residential market and the low-end commercial market. So we wouldn't be doing megawatt type plants, but we'd probably do up to 500 kilowatt hour plants. So that's kind of our niche that we play in. So really, this video is about how do we go about making sure we get the right size system for your premises. And I'm going to go through the process that we go through to get to some kind of numbers and sizing of inverters, number of panels, sizing of batteries, just so that you can get an idea of the challenge that you face if you get the sizing wrong. I think the biggest thing is to understand what your usage is like. And with a new house, it's quite difficult because you haven't lived in there. We can't go and log any current usage. But what we can do is we can look at your current usage, compare the premises, look at any new appliances. Maybe your current house doesn't have air cons, but the new one does, and you want to have them on backup. So even when it's hot, they can be powered. So it's all those variables that we have to look at. So I'm gonna take you through that, and and then any questions that emanate can be rerouted back to me. But yeah, thank you very much for viewing, and I hope this is enlightening for you. Right, so this is actually another site in Pazula, also being constructed at the moment. So what they've done is they've taken their current usage from their house in Johannesburg. So we've got the various bills, and you can see how many days and how many kilowatt hours they've been using and per day. And we're taking it that they're going to have a pretty similar style going forward when they move down to Pazula, obviously at different rates. So this is the Knysna or George tariff rate, and we've used 6 months to get an average, and then we move across. All right, so if we move across to the input, which is down here, then we'll capture the numbers from the other side, so number of days, usage for the period, and so on. I won't go through in too much detail, but then we get to sizing the PV. So we'll go here. We're going to be in the Eastern Cape, which, if you can see down here, is 5.5 sunlight hours a day on average. We need 18.6 kilowatt hours a day, and we're going to use 625 watt panels. But how many do we need? So with that many sunlight hours, each panel will make 2.75 kilowatt hours per day. So we will need 7 panels with an annual production of 7,000 kilowatt hours, or 7 megawatt hours, and it'll produce 19 kilowatt hours per day. So we needed 18.6. It's going to make 19.2, so that's 103%. Okay, so this is the table where we have the lookup table for the various regions. It'll give us this is the average sunlight per day. So it takes winter, summer, everything into account, but it's that average. So the whole model is based on averaging. We want to get the big picture for the whole year. So that's where we go and look those up, and those are provided by the SA Weather Bureau. Okay, so then that then feeds into my quote. I've blanked out obviously the numbers here individually, because obviously it's That's privy only for the customer, but you can see the totals. It's 136,000 Rand system for a 8 kilowatt inverter, 10 kilowatt hour battery. So the inverter is the thing that basically has to pass through the power that you want to have backed up and on the inverter. So it has to be of a certain size. So a kettle, for example, uses between 2 and 2,500 watts. So you can see it takes a big chunk out of 8,000 watts. Now you put on a toaster and a kettle, so suddenly you're at 4,000 watts. So you're half of the inverters. Now you get to maybe 9 or 10,000 watts, the inverter's going to trip, which is very annoying. So getting the sizing wrong plays back onto us as a supplier, because you're the person who has to live with it. So we need to get the sizing right. And we do that by looking at the plans, looking at what sort of house it is, what sort of appliances they are anticipated to be there, and we then size from that so that you can enjoy the system and not be moaning about it all the time. The battery, again, is about not only the backup facility, it's also about doing what we call peak shaving. That's the practice of making solar power during the day and charging up the battery, and then saying, okay, you're allowed to use maybe 50% of the battery in the evening. So between sort of 4 o'clock and 8 o'clock, or as long as the battery lasts, down to 50%. And then the other 50% is reserved for backup. So every single day you will use the battery. It's not only when there's load shedding, you will use it every single day to cut your electricity bill. So the power you've made during the day will be fed back into the house via the battery in the evening. These are bifacial solar panels. They're also what you call all back contact, so they have a very high shading tolerance. You can see 625 watts and 7 panels. We have to deliver this system out of Cape Town, so there's a delivery charge. And then the installation, commissioning, cabling, switchgear, which is all of the cables and mountings, etc., that go into what we call the balance of system. That would be a number in here, somewhere between 25 and 45,000 Rand. It's a lot of work, and it has to be properly approved, not only by the COC, but also by your local council and the estate. So we would have to send a copy of it to Pazula for them to approve it as well. And I'm very familiar with this from doing lots of houses in places like Dainfern and so on and so forth. So so that is how we come to our number. Okay, so here is our total amount spent, and this is a simple cash flow and savings graphic representation, so that people can get an idea of, when's this thing going to pay me back and how much will I save. So essentially, this is when you're going to get paid back. So you'll get 114k of your 136k back in year one, and so on and so forth. And that's graphed over here. And you can see year 5, you'll go cash flow positive. And then savings, obviously you make savings from day one, basically. So in year one, 21,711 Rand. And that's based on what you have, the amount of energy you've produced, which has been replaced the grid. So 21,000. And then that in the second year increases to 24, and so on and so forth. So yeah, that's just something I like to do to show people where the money is, and what the system's going to do from a financial perspective. Okay, so on the screen now is a 5 kilowatt, which is great for smaller residences. It's 5,000 watts, so if you've got your normal fridge, freezers, that type of stuff on it, you're probably going to run, in a small house, will run about 600-700 watts constantly, even through the night, because you've got various things on. But then once you put a kettle on, as I said, it can be 2,000 to 2,500 watts. So immediately you've kind of gone up to 3,500 watts, say, and now you put something else on, like a toaster or a vacuum cleaner, something like that, and the inverter trips. So 5 kilowatt has its place. You can also limit what you put onto the system. So you could say, I only want to have my plug circuits, which are TVs, fridge, freezers, DSTV, and that's it. I don't want to have kettles and whatever else. So it'll be fine for that. And it will give you a little bit of peak shaving as well. So yeah, it's got its place, but certainly I think it certainly applies to smaller premises. Okay, so on the screen now is the 10 kilowatt, also a Fox, which is the manufacturer. It's a high voltage inverter, which is quite important. High voltage, so it's about 380 volts versus your normal 48 volts inverter. And the advantage of that is it charges your battery a lot faster, uses thinner cabling, and responds to high demand current much better than a low voltage system. So yeah, this particular system has 10.5 kilowatt inverter and 12 kilowatt hours of battery. It's in our home in Dainfern, so a fairly large house. We also have the geyser on a separate, same solar panels, but a separate solar system. So the panels are all uniform on the roof. So this system is connected to one of the three phases. The other two phases of electricity supply feed the geyser when it needs grid power, and feeds the oven and stove in the house. So those are off the inverter because they're too high load for even this inverter. But it is probably the sweet spot for a larger residence. Sort of, and people always say, what size inverter do I need for a 4-bedroom house? But it's not really that. You can have 2 4-bedroom houses that use power very, very differently. So, however, this particular inverter has been very successful in those size houses with very, very few trips. Only when there's very, very high demand on the house do we ever see that, and that's quite seldom. But we monitor also all of this all the time off site. So we have apps that monitor this. And yeah, so I think it's kind of the sweet spot for the residential market because it does what it's supposed to do, and it can certainly be expanded, and you could even expand to another inverter at some time if you ever need it, but I would doubt it. But you can certainly expand the batteries, in 5 kilowatt blocks. Okay, so the inverter shown here is not Fox brand, it's SunSync, which is a very popular brand. It's a 16 kilowatt hour, 16 kilowatt. We talk about kilowatt hour in terms of batteries and kilowatts in terms of inverters. So it's a 16 kilowatt inverter. Very large house in Bedford View on the side of the hill there. And the battery is a 20 kilowatt hour battery. It's got various Pylon-Tech batteries inside that cabinet that's shown there. And then it has a big solar array on the roof. And yeah, so this is also a possibility, I would say, for maybe one of the larger homes in the Pazula estate. But probably the 10.5, as I said previously, would fit most homes. But yeah, this has been a very successful site and has run pretty harmoniously without any intervention from us. So quite proud of this one. Okay, finally, the solar panels. This is an array that's on a flat roof, so we've used concrete ballasting and triangular mounts to put those panels up there. We don't want to have any brackets that are bolted through a flat roof. Those always tend to leak, so we don't penetrate any roofs. Even on a tiled roof or a clip lock roof, we just use clamps that clamp on and are secured, and particularly in an area where you're on the coast, wind can be a massive problem. So you've got to make sure that is done in accordance with the worst weather conditions that we have seen recently. So we're very particular about that. So this particular roof is here in Johannesburg, but at the coast, I think the winds tend to be a lot higher. So there does need to be a lot more consideration of that. The other thing we've got to consider is weight. So solar panels are getting pretty heavy because they're getting bigger. So where they used to be sort of 25 kilograms, they're now 31, 32 kilograms. And you've got to watch out for your roof loading limit as well. So we take consideration of that. And there's quite a lot to think about: cable routing, and the various other things. Of course, lightning is an issue. So we earth everything, and we have surge protection devices on all the lines, and that's a very important aspect, and something that some installers cut corners on, because the homeowners or the customer is not aware of all of that until something goes wrong, and then often you're left holding the baby, as it were. So yeah, that's a little bit of things to think about in terms of solar panels, inverters, inverter sizing, and how we arrive at our numbers.